Hi, I'm Dr. Simon Holland, CEO of Barefoot Lightning, and I want to tell you a little bit about the journey we've been on as we've been looking at how to address animal health and nutrition in smallholder farming systems. A project started really when I moved to India in 2004 and started working in organic agriculture systems, really looking at how we could make the certification process more effective and more useful to the farmers. What we saw, though, was that almost all the farms that we went to, livestock were incredibly important, both for providing fertility to the fields, but also as a way to actually look after the farmers when they had times of difficulty where they could cash in the animals to support problems they were facing. So we built this platform up through a number of projects. The first one we started on was a simple probabilistic model where we were working with Leeds University and the Centre for Decision Research in the UK, and also looking at Indian cattle and how we could develop simple probability models to really support disease diagnosis. That led to a project in Ethiopia with Liverpool University Vet School, and there we were looking at backyard poultry, and we really discovered the power of animations to communicate symptoms through this project. Next, we worked on large-scale pig systems in Kenya, working with ILRI, the International Livestock Research Institute, and Farmer's Choice, which has a 70% market share of the pork processing in Kenya itself. So working really here with very large scale farmers, but also pulling in government to understand the challenges that they faced. And what we discovered was, though the farmers were desperate for these types of solutions, the government vets felt they really wouldn't meet the regulatory requirements of needing a vet in the diagnostic chain. So actually, it taught us a lot about how to adapt to actually meet the requirements of the veterinary extension systems. Then we did some project work in cattle in Malawi, where we really were looking at how to pull in milk collection centers as a coordinating unit for the delivery of these types of extension services. And more recently, we had a project with Bill and Melinda Gates Foundation working on goats and sheep in India. And here we were doing a lot more innovation around the business models and how to make those work so that we could make the whole system far more sustainable. So let me tell you a little bit more now in detail about the health platform. So in terms of how we work with community animal health workers, with paravets and field or extension workers, and we look at how we can connect them to vets as well. It is important to have multiple revenue streams in there, otherwise we can't make the system self-sustaining. So we've done a lot of work on that. But one of the biggest challenges is that when a paravet or even a community animal health worker goes to a site, they won't get paid unless they treat or prescribe an animal. So we've got to somehow figure out a mechanism to stop what leads to an overprescribing of antibiotics in the whole channels. And how we've done this, okay, so what we have is a platform, and this is for paravets, where we will show animations of different symptoms. And so they can check different animations and see, yes, this is what I think the problem is. We also have photo bank and video banks available. But as you can probably see from this image, unless you're a trained vet, and even if you are a trained vet, it's not always easy to actually be able to identify what symptom you're seeing in front of you, which is why the animations work so effectively, because they give a concept of a symptom and help people to understand how to then make a choice of those symptoms. So in terms of making that choice, that information then is fed to a vet for review. And I'll go in a bit more detail of how we support the vet to do that review. But they can send back more symptom requests. And even we have some algorithms that mean we get about 6 symptoms in between before the data reaches the vet so that we can do some additional disambiguation between diseases. So once they're ready, the vet can now do a diagnosis and send out a prescription. And we're also linking to additional diagnostic tools where we might take samples for lab testing. But once they've done that, we can also then get a follow-up of what was the outcome. And this allows us to build a picture of either our diagnosis probability or our prescribing engine are not being effective, or perhaps a resistance is developing in a local strain. We've then done some work with the National Physical Laboratory in the UK to build a machine learning probability model that allows different regions now to actually inform the model through the vet diagnoses. And this means that different strains, which might display different symptoms in different livestock populations, over time get taken into account in the model. So how we work with the vets, so we have a dashboard that gives probability of the model. We also now have built in, through the work with NPL, the animal context. So is it an old or young animal? Is it pregnant? The farm context. So is this a large farm with a lot of animals all breathing on each other, leading to a lot of respiratory disease? Or is it a small farm with a dirt floor where soil-borne diseases become more important?